Today we're going to talk about the difference between units and dimensions. This is an important fundamental concept whenever you're working with any sort of environmental data or really any data at all. Units are extremely helpful because they can help us figure out ways to calculate something that we're trying to figure out, even without having formulas. If you just follow the units and look at them, you can usually figure out a problem without having to have an inherent formula available to you. So first off, let's talk about dimensions. There are 7 primary dimensions: length, mass, time, temperature, amount of light, amount of matter, and electric current. For the purposes of this class and this lecture series, we're only going to talk about the first 4, which are pretty basic. We all know what length is. Mass is on Earth equivalent to weight. Time, of course, is just time elapsed, and then temperature, of course, is how much heat is contained within a substance. Dimensions are the most basic way we can describe the physical world, so they're much more basic than units. Units are types of dimensions or specific instances of dimension. So let's look at some examples for how we can describe the physical world using dimensions. So if we have area, right? So area is length times length. How would you think that we would, using the 7 primary dimensions, describe area just using dimensions? Well, you can use, since area is length squared, you can just write area as length squared. So it's, if you think about a 1 foot by 1 foot area, if you multiply those times each other, you have 1 square foot, right? What about if you had volume, right? So volume has 3 dimensions in there. How would you describe volume using just dimensions? Well, since area is length squared, volume would be length cubed, right? If you have a box that's 1 foot in length, 1 foot high, and 1 foot deep, you would go 1 foot times 1 foot times 1 foot to get 1 cubic foot box. So this is the same, it's just saying length squared, or length cubed rather. Units put dimensions into a context that we understand, right? So length can be very different. You could be talking about length of cells that you see under a microscope, or the length between objects in the universe. And those are obviously very different scales, so we need units to put some context to that. And this is also how we can quantify dimensions, because dimensions is just length. Length itself doesn't have a specific measure, right? It's just describing some aspect of the physical world. So for practical purposes, we assign units to dimensions. And there are 3 different basic unit systems. There's the imperial system, which we think of as like inches, pounds, feet. And there's the metric and the international system of units, which both overlap a lot. So these are things like meters and kilograms. And since we have a good understanding of dimensions, we can go between these different systems of units pretty easily. So working together, let's look at some examples of dimensions that are in units. So for length, we could have meter, metric system, inch, which is imperial system, or foot, which is imperial system. We also have large units such as astronomical unit, which is the distance from the Earth to the sun. We also have mass, so that might be in kilogram, gram, or pound, ounce, are all units of mass. Time is pretty standard. There's minutes, seconds, and years, or millennia, but that's standard across different unit systems. And then for temperature, there's 3 basic temperatures, which is degrees Fahrenheit, degrees Celsius, and Kelvin. Units, as I said before, are very helpful because you can use them to figure out how to calculate a problem, even without having a formula. So let's say that you want to know the rate that a boy grows during puberty. right? You know the rate is going to have units of inches per year, so you're given that the end units are going to be inches per year, and you have one particular boy that you're going to figure out the rate that he grows, and you know he grew 14 inches over 7 years. So using the units as your guide, how would you figure this out? Well, you know that the end units are going to be in inches per year, so that's inches over year. So you would put 14 inches divided by 7 years to get the final answer of 2 inches per year. So he's growing pretty fast at this point in time, or over these 7 years. So here, just by looking at the end units you know you're supposed to have and the units you're given, you can figure out the calculation that you need to get the answer. So what are the dimensions of this example? The units are inches and year. What would the dimensions be of that? And that would be length over time, because inches is a unit of the dimension length and year is a unit of the dimension time. Let's look at another example that's maybe not as obvious. So let's say you want to know how many coyotes live in the state of Nebraska. Your final answer is going to be have units of coyotes, right? So you want to know how many coyotes live in Nebraska? That's going to be the final unit. How many coyotes are in Nebraska? You're given that you know that Nebraska has an area of 77,421 square miles, right? And you also know that there's an average of 38 coyotes per square mile in the state of Nebraska. So you got a lot of coyotes in Nebraska. How do you use the units to figure out what the calculation is? Well, we know that our final calculation needs to have units of only coyotes, so we need to get rid of those square mile units. We need to cancel them out. So that would look something like this. We'd multiply 77,421 square miles times 38 coyotes over square miles to get our final answer of just under 3 million coyotes. So in this example, the square miles are going to cancel each other out, because the 77,431 square miles is essentially on the top of a fraction. So you could think of this as that number over 1. And then times 38 coyotes over 1 square mile, essentially. So in this case, the top unit on the left, square miles, is going to cancel the square miles to the right of the multiplication sign. So again, what are the dimensions of this example? We have square miles and we have coyotes. What are those dimensions of? And the answer is that coyotes, essentially we're looking at mass here, we're looking at how big they are, right? So the mass represents the coyotes, and then length squared represents the miles squared. So why not just use units? Why do we need to think about dimensions? Well, you could think about languages. Why don't we just have French and Spanish and English? Those are basically instances or examples of languages. So in this case, languages are a broader classification. Languages are akin to the idea of, having this idea of what a language is akin to the idea of dimensions, and having specific examples of languages are akin to the ideas of units. So we kind of need that larger context to put these units into and to classify the units. That also allows us, since we can classify them together, like miles and feet and meters and centimeters are all instances or examples of length, that allows us to convert between those different types of units rather easily, because we have them in this classification system. Also, some field of science, like theoretical physics, might not use units at all. They only operate in dimensions because the units don't really so much matter for them. So we need to have this broader context available for those types of sciences. And that is the difference between units and dimensions. I hope you found this useful. And don't forget, you can always come back and watch this video again if you're having to think about how to use units to convert or do different calculations.